A documentary about the birth of the SU-100, the outdated cabin, the pragmatic D-10S, and the battles from Budapest to Balaton. How a simple structure became a pillar of the front and cast a long shadow from Prague to Suez. At the beginning of 1943, it seemed that the dispute had been resolved. The future belonged to turret machines. The experience of evacuations and disruptions during the first years of the war receded. Technology stabilized. The T-34 took on a mature form, and the logic of the universal tank looked like there was no alternative. In this logic, a self-propelled gun in the wheelhouse seemed to be a temporary measure. A box with a large barrel instead of a real tank. Simplification for the sake of release speed. There was both irony and doubt at the design meetings. Why cling to a scheme where the barrel guidance sector is strictly limited by the hull, if the turret is able to respond to threats from all directions, support infantry in street combat, and fire on the move? The answer seemed obvious until facts, not slogans, began to accumulate on the front line. The Kursk bulge destroyed such confidence. In the areas where the Panthers and Tigers appeared, the usual answers stopped working. The infantry needed mobile anti-tank weapons capable of conducting targeted fire at real distances and holding the enemy's return fire. The tower provided a wide range and convenience of all-round combat, but it ate up the mass, complicated production and operation, and required careful adjustment of the running gear. The conning tower layout, on the contrary, was drawn to technological simplicity. Fewer complex moving units, a more rigid forehead, and a compact silhouette. Where it was necessary to quickly increase the number of vehicles with powerful anti-tank weapons in the troops, these qualities turned out to be not a journalistic, but a completely practical argument. The SU-85 became an intermediate response. The regiments quickly learned how to get the most out of it. Block the directions of attacks, line up bags, and change positions before the enemy could shoot down. But it soon became clear that the 85mm cannon in the far reaches no longer guarantees the solution of the problem of hitting the Panther's forehead. In the reports, the formula, "we hit, we don't solve," appeared. The armor held the hit, the initiative eluded. It looked like a rebuke to the cabin itself, although the impact was on the energy of the projectile and the caliber requirement. The essence of the dispute shifted. The question was not whether the wheelhouse was outdated, but which platform would accept a gun with a different ballistics and a rollback mass faster and more reliably. Here, the same outdated scheme came to the fore as the carrier of a more powerful barrel. The wheelhouse made it possible to fit a heavy swinging part without acrobatics with tower balancing, and the frontal assembly withstood the reactive loads of the shot. The fewer high-precision rotating units there are, the fewer reasons for failures in dirt, dust, after crossing fords and marching along broken roads. In the engineering tables, it looked prosaic. Welding tolerances, axle mounting tolerance, and linear bearing life. In practice, it requires more time to fail and a steady pace of production. In the conditions of the front, a simple car did not become poor but disciplined. It drove, fired, and returned to service faster. Opponents of the scheme rightly recalled the limited sector of horizontal guidance, the dead zones of close combat, and problematic defense in urban areas. In the assault role, the lack of a turret machine gun made the vehicle dependent on infantry cover. The calculations included seconds of conversion of fire by the hull, loss of accuracy during maneuvering, and increased time to find a target. However, in defense, in pre-prepared positions, these disadvantages were partially compensated. The sector was selected in advance, the landmarks were targeted, the rollout and rollback were practiced, and the gaps between the firing fans were blocked in pairs. Where the first shot decided more than the flexibility of a duel, the chopping won. Where constant micro-rotations and fire at soft targets around were required, the tower won. The lessons of 1943 can be summarized in a few simple theses. First, ballistics is more important than symbolism. If the gun pierces the target at a distance where return fire is less dangerous, the crew gets the initiative and the right to choose the moment of battle. Secondly, technological efficiency is also an armor, only organizational. Unified nodes reduce downtime, reduce the burden on repair units, and stabilize output. Third, the low silhouette, hard forehead, and competent seating of the crew do not replace tactics, but expand the field of tactical techniques. And fourthly, layout is not an ideology, but a way to honestly pay for the necessary characteristics in the given resources of time, metal, and qualifications. It is important not to confuse journalism with protocol. No one literally laughed at the cabin. There was a harsh, sometimes caustic, but professional polemic. In the design bureaus, they leafed through tracing papers and summary sheets. The distribution of masses along the axes, ground pressure, stability when fired, ventilation paths, and the convenience of laying ammunition. In parallel, alternative branches were running, turret vehicles with enhanced armament, and a whole range of self-propelled guns, from assault to anti-tank. It was not the rhetoric that won, but the table. What can be done quickly, stably, and without compromising the life of the chassis? The question, whose scheme is more modern, turned into the question, which scheme is more reliable to get to the part and work out the task? In this table, the cabin won with its earthly common sense. It made it possible to place a longer barrel without radically redesigning the machine's power circuit, strengthen the forehead, facilitate gun maintenance, and simplify the ventilation of powder gases. Its shortcomings were known and taken into account by the regulations and crew training. The machine learned to live in pairs with infantry, work in groups, change position after each shot. Do not linger on the ridge. Go to reserve lines, where the aiming angles again became sufficient. This discipline of the sector gave rise to a whole set of techniques in which the wheelhouse felt no worse than the tower, and sometimes even better. There was a continuous evolution going on inside the cabin. The commander's visibility was improved, the aiming devices were improved, the laying was revised, and the geometry of the workplaces was changed. Fine ergonomics, the distance to the flywheels, the height of the seats, the location of the rollback hydraulic shock absorbers, the trajectory of the sleeve movement, gave a significant increase in combat capability. These little things don't catch your eye in the photos, but they are what turned the scheme from yesterday into an actual one. The designers learned from the troops as carefully as the troops learned from the designers, through comments in magazines, through improvements in the series, through rapid changes in the equipment of workshops. The paradox of the 1943 dispute is that both sides remained right within their limits. The tower is really better suited for maneuverable combat, for breakthrough and street fighting. The conning tower is indeed better suited for defense, anti-tank ambushes, and firing bags, where the first shot and recoil resistance are more important than the instantaneous transfer of fire to 90 degrees. The Eastern Front required both, but resources forced a choice. Choosing a powerful self-propelled gun turned out to be not a step back, but a sober risk management. A bet on a clear chassis, a technologically advanced armored box, and a gun that reaches the target before the target reaches you. This is how the frame of the future SU-100 was formed. A familiar chassis, a layout mastered by industry, and a gun capable of dictating the combat distance. The dispute has not disappeared, but it has lost its acuteness. It has become a working procedure for comparing options. The wheelhouse has ceased to be a symbol of poverty and has become an honest engineering platform for the barrel, which changes the behavior of the enemy. This is the main lesson of 1943. Reliability is not an abstraction, but the sum of reasonable constraints and precise decisions made on time. The result is simple. The cutting gave the front a powerful barrel without the cost of disrupting production. In 1943, this was synonymous with reliability. When they say engineering pragmatism, they are not talking about spectacular slogans, but about tolerance tables, routes of parts through workshops, bearing temperature after hundreds of shots and access time to filters. The SU-100 grew out of such prose. Uralmash and the Design Bureau of Plant No. 9 rejected the cabin versus tower dispute in advance as a poor formulation of the issue, and formulated the task differently. To put a barrel in a proven chassis that really solves armored targets at the front ranges. To ensure the rigidity and adaptability of the installation. To ensure that the machine can withstand long marches and long firing sequences without vagaries. This is how the words reliability and simplicity turned into specific solutions for nodes and technological operations. Choosing a cannon has become the heart of the project. At the beginning of 1944, several 100mm solutions were discussed, but it was the D-10C, the self-propelled version of the D-10 cannon from the FF Petrov team, that provided the necessary combination of factors. Ballistics made it possible to confidently hit the Panther and Tiger at ranges where return fire was already losing accuracy. The long barrel, the high initial velocity of the armor-piercing projectile, and the stability of the midpoint of hits during long bursts did their job. For the front, this meant a simple thing. The crew gets the right to choose the moment and distance of the battle, rather than spinning under fire hoping for luck. To prevent this energy from turning the ACS into a one-time attraction, engineers took up the mechanics of the shot. The rollback length was recalculated. The volumes of the hydraulic shock absorbers and the parameters of the knurler were adjusted, and the mass around the trunnions was rebalanced. The forehead of the hull was thickened, the gun mask was redesigned for increased loads, and the cradle attachment points were strengthened. The task was specific. After the shot, the car should not nod with its nose, and the barrel must quickly return to the line of sight without unnecessary hesitation. In the language of crews, this turns into seconds that decide the outcome of the duel. The ammunition for the D-10S was used separately shell-cased. Yes, this is more action for the loader and higher training requirements, but the mechanics are more reliable, and the range is wider. Armor-piercing, low-caliber, and high-explosive shots were selected for the task. The designers compensated for the human load with ergonomics. The stowage was deployed so that the most popular ammunition lay in the zone of minimal movement. The feed trajectory to the loading line was shortened. Convenient foot and shoulder stops were added so that the working movement was short and repeatable. Efficient exhaust fans on the roof of the cabin and a well-thought-out breech purge prevented powder gases from accumulating in the habitable volume during intensive firing. In total, this reduced the fatigue of the crew and maintained the rate of fire throughout the battle. The second pillar is unification. The more details match the T-34-85, the fewer risks there are in the series and in the troops. The power plant remained in the B-2 family. Transmission and chassis, with the usual rollers, gearboxes and tracks, electrical equipment and spare parts, from the mastered batches. The geometry of the cutting was adjusted to the existing slipways, so as not to slow down production by retrofitting. This soft discipline meant the main thing for the front. The car arrives on time. The repairmen know it from birth. The warehouses understand what to keep and in what volumes. Unification is not just about screws and nuts. It's also about the speed of learning and reliable logistics. Surveillance and communications have been brought to a level consistent with the power of the cannon. The commander received a turret with all-round viewing devices, and the tunnel vision of the previous self-propelled guns disappeared. The radio station became more stable on the move. The cable wiring was removed from hot and moving areas. The guidance flywheels were adjusted to an easy, smooth ride without backlash. The sights received clear scales for the main types of projectiles. All in all, it took seconds, but it was seconds that decided who would be the first to pull the trigger when the frontal projection of a solid slab flashed on the horizon. The culmination of pragmatism was the state trials. A typical battery cycle was simulated at the training ground. A march, an exit to a position, a sighting, a series of armored targets, a change of position, and a repeat. The car was driven along roads and virgin lands, over rough terrain and in mud, and long bursts of gunfire were fired at varying rates. The testers recorded everything: overheating, displacement of the midpoint of the hits, cracks in the seams, backlash in the supports, vibration behavior of the sights, ventilation efficiency, accessibility of the nodes under the regulations. Any weakness at such a distance is bound to show up, and it's better to let the firing range see it, rather than the calculation under fire. As a result, individual mask elements were strengthened. The fan mounting was changed. The welding technology at loaded joints was clarified, and the location of some maintenance hatches was adjusted. These strokes are almost invisible in the photos, but they increase the resource of nodes and eliminate unexpected downtime in parts. At the same time, technologists adjusted the design to the capabilities of mass workshops. Casting and rolling were distributed between the sights so that narrow necks would not form, and the transport shoulders would not eat up the rhythm. Where this did not harm durability, complex parts were replaced with assemblies from simple profiles. The welders were given seam maps with realistic tolerance shelves, which are provided with an average qualification level. Control was focused on the nodes where the error is fatal, and not on decorative polishing of the edges. The result for the front sounds simple. The output has become predictable, and the quality has become even. The conning tower layout itself was a form of reasonable economy of complexity. The absence of a heavy turret shoulder strap eliminated dozens of high-precision operations and made it easier to seal against dust and water, while the low silhouette reduced the visibility of the position. Instead, the requirements for the ideality of the cannon installation unit have increased. Alignment, balance, and clean handling of the trunnions and rollback mirrors had to be maintained flawlessly. The designers deliberately transferred the complexity from the corpse to the artillery unit, where it provides a direct increase in combat capability. At the exit, the gunner received a machine that behaves predictably. The rollback is extinguished smoothly. The return to the sight is fast, and the first accurate shot does not turn into a rare miracle. Life also intervened in the calculations. The SU-100 improved access to filters and candles, built intersecting routes, moved interfering elements from the charging area, and added convenient hatches for regulations. The driver was able to remove and install a number of units by the crew, rather than waiting for a repair job with a rare tool. These little things rarely get into the legends, but they add up to the failure time and the reputation of the car as tenacious. The training units won no less than the factories. Crews and repair companies, accustomed to the T-3485, switched to the new ACS without breaking habits. The engine is familiar. The chassis is familiar. The electrics are recognizable. This saved weeks of study time and accelerated battery commissioning. Unification doesn't just work in the spare parts warehouse. It works in the heads and hands. Compromises, of course, remained. Separate loading and cramped conning require training and coordination. The horizontal guidance sector is limited. Infantry is especially important for close-range defense. But pragmatism manifested itself here in the honesty of the task statement. The SU-100 wasn't trying to be a universal Swiss knife. It was created as an anti-tank tool that destroys armored targets at a favorable distance, acts as part of a unit, and quickly changes position before aiming at it. The result of this line is simple and convincing. The D10S gave range and penetration. The cutting provided rigidity of the installation at a reasonable price in metal and operations. Unification with the T-3485 eliminated logistical risks and accelerated the preparation of calculations. The state tests played the role of a filter and a press at the same time. They sifted out the excess and squeezed out the weak before the enemy did it. By the time the SU-100 series was launched, it did not look like a spectacular novelty, but a mature tool in which every detail is subject to one criterion: to hit on time and live between shots. The winter sky over the Hungarian plains held a low gray roof, and this played into the hands of those for whom the first shot solved more than the subtle juggling of the tower. The self-propelled guns with D10S that appeared on the outskirts of Budapest entered the battle quietly, almost casually. They were brought out not as a miracle weapon, but as a tool designed for a specific set of conditions. Ranges at which the Panthers are still visible, but no longer omnipotent. Positions where you can shoot landmarks in advance. Fire discipline, where 1 accurate is more important than 5 fast. In the January battles near suburbs and road junctions, this math was quickly confirmed by practice. The first experience came through bundles of machines and modest techniques. The crews learned to position the SU-100 under the ramp with the possibility of a short rollout into the firing line, so that the barrel would come out and the hull would remain covered with earth shafts and landings. Short message moves were laid between the positions to change the sector after the series. The topography of the area was tailored to suit themselves. Vineyards, ditches, railway embankments turned into elements of a predetermined geometry of the battle. When the Panthers advanced to counterattack, the SU-100 batteries opened the fan, overlapping the zones so that any maneuver of the target would fall into someone's aiming diagram. In street construction, other factors determined the result. But in the fields and on the edges of forest belts, self-propelled guns confidently took the initiative, forcing the enemy to either hide or approach the lines where his armor ceased to be an argument. Distance discipline has become a major virtue. On bright, frosty days, the observers caught black silhouettes against the background of snow bands and transmitted calculated ranges to the gunners along a grid of landmarks. The D-10C made it possible to work in what reports call exceeding the capabilities of the target. The Panther's forehead still held something on paper, but in real combat, a mixture of terrain, meeting angles, and armor-piercing energy provided crucial centimeters. The gunners noted the predictability of the installation's behavior after firing, the short cycle of returning the aiming line, and the hand-pleasing operation of the flywheels. These are not spectacular characteristics. Posters rarely write about them, but it was precisely such boring mechanics that added seconds to survivability and removed the degree of randomness. February and March brought the climax. The German offensive at Lake Balaton, carefully prepared and believing in surprise, ran into a well-assembled, albeit fragile, defense. The fields between the Balaton and the Danube, intersected by canals, forest belts, and drifts, forced the attackers to open up in wedges where the defense could shoot them one at a time. The 6th SS Panzer Army was leading heavy tanks, Panthers, and assault guns. Shock groups were to cover them from the sky when the weather cleared. The defenders responded with a network of anti-tank strongpoints, where the SU-100 played the role of a long-range ridge. The front edge was saturated with smaller caliber anti-tank missiles and mines, and behind them, at advantageous heights and boundaries, there were batteries with D-10s, ready to meet armor at distances where the strike was economical and destructive. The classic technique looked simple. False positions with obvious signs of activity were set up in front of the defense front in the selected directions. The enemy embraced them with artillery preparation and spent time on deployment. The real firing points remained silent until the moment when the lead vehicles, having found the holes, took out the sides at angles convenient for hitting. The first episode dealt with witches and the suppression of recognized spotters. Then they caught up with the tail and communications in order to break the controls. Changing positions was a strict norm. 1 or 3 shots, rolling back, shifting to a spare pocket. By pressing the Panther wedges, the self-propelled guns did not engage in a boxing round on short ones, where they had a chance to realize the view and maneuver of the tower. Instead, they imposed a chess pace in terms of distance and time. Real terrain rarely follows a perfect diagram. The spring waters washed away the roads. The night frost bound the soil with a crust. The daytime sun returned the dirt. In this change of aggregate states, the T-34 chassis provided the necessary tolerance for clutch failure, and the low silhouette of the SU-100 made it possible to look for cracks in the folds. The crews settled into copses and plantings, where even the tall trunk did not give them away until they were rolled out. Communications worked in a tight grid. Section commanders suppressed the desire to put the squeeze on and kept in mind an important rule. Do not waste a long-range vehicle on a close-range firefight where chance becomes an equal participant. The word sustainability is often found in the reports of those days. Resistance to grueling marches with frequent changes of direction, to dirt in the mechanisms, to long runs at the turn. The D-10s endured the battle as expected in the design bureaus. The recoil was extinguished smoothly. The breech did not twist the calculation, and the aiming did not go into the sky after the 3rd or 4th shot. Where physics had to be negotiated with physics on the predecessor, physics worked on schedule on the SU-100. Yes, there were back accounts. The cramped cabin forced the crew to maintain strict order in the stowage. The limited horizontal guidance sector required well-thought-out joints with neighbors. The lack of a directional machine gun increased dependence on infantry, especially in defense breaches. But these disadvantages were offset by the main gain, the opportunity to beat the armored targets, keeping them out of the miracle zone. There were also difficult episodes when the Panthers imposed close combat. Then the battery's internal dress codes came into play. The commander turned into an assault configuration. Double positions, cross sectors, short rolls with high explosive on soft targets, in close cooperation with machine gunners and sappers. But even in such scenes, trying to fight like a tank was seen as a bad idea. The SU-100 achieved results not by trying to become a turret, but by persistently remaining a self-propelled artillery with an anti-tank mission. A shot from an advantageous position, instantaneous position change, repeat. The culminating days at Balaton showed another side of the engineering choice. Unification with the T-34 made the batteries maintainable in the field, where every day disrupted supply plans. The filters changed quickly. The plugs and injectors were familiar. The boxes did not require a rare tool. Cracks in the loaded seams were tracked using clear control maps. The machines lived between shots not by luck, but by predictability. When the battery keeps the stated pace, the commander calculates the actual firing line, not a dream. This is what will later be called circuit reliability. Budapest's opening and the Balaton defense formed a common lesson in tactics. The SU-100 worked best as a long-range skeleton of anti-tank defense, with flexible maneuver muscles. She loved a field where you could choose a range. She tolerated rough terrain where the terrain hid the hull. She did not forgive the fuss, where shooting immediately turns accuracy into a lottery. Her strength is not in a spectacular throw, but in an overwhelming first shot, followed by a quick exit from under return fire and a new point. In this logic, the Panther ceased to be a symbol of horror and became just a task for the right solution. In the spring, when the attack on oil turned into an empty sound, it became clear that the perfect choice of layout and guns worked out the calculations invested in it. The SU-100 was not looking for the glory of singles. It was honed for a systematic battle. Where the system failed, the Panthers ran into an invisible wall of long-range barrels. Where the system crumbled, any iron became brittle. This difference is the meaning of the winter-spring battles. The engineering pragmatism embedded in the D10S, and the wheelhouse turned into tactical freedom and strategic predictability in practice. And predictability in war is sometimes more valuable than the brilliance of new products. The frontline reputation of technology does not consist of parade figures, but of boring little things. How quickly it starts in the morning cold, how predictably the clutch turns off in the mud, how many mats it takes to remove the fan, and whether the calculation will be able to drag the spare truck without the help of a repair kit. Soviet-style reliability, in the case of the SU-100, is just such a set of everyday virtues and misdeeds. The machine wasn't magical. It honestly paid for the powerful D-10C cannon with its cramped, limited guidance sector, and reliance on infantry at close range. But in return, it provided what was valued most at the front: predictability and maintainability. Let's start with the heart and legs. The V2 diesel engine of the T-34 family for self-propelled guns is a pragmatic solution. The resources known. The nature of the vagaries is clear. Spare parts and regulations are tested in the troops. The V-shaped 22 did not like dust in the filters and dirt in the fuel, but it tolerated barbaric treatment better than many refined engines. The main thing is to keep filtering and not overheat. On the SU-100, maintenance was simplified directly by design. Access to air purifiers and wear elements was done through convenient hatches. Wiring was removed from hot areas, and possible leak sites were marked so that the driver could see them at the first inspection. As a result, the morning launch at -10 turned into a procedure, not a lottery. On the marches, the diesel pulled confidently, and if you did not force the box on the viscous ground, the overall survival rate of the power plant remained high. The box and the main gears, the legacy of the T-34 school, were both a blessing and a source of familiar trouble. The fighters like to joke that the first one is philosophical and the third one is characteristic. In the sense, it requires character to enter without creaking. In fact, the coordination of mechanics and proper traction control worked wonders. When trained correctly, the gears turned on smoothly, and the jerks when moving the body for guidance remained within the limits that did not kill the sight. Exhausting areas on heavy ground were considered a weak point. If you pulled for a long time in an unsuitable gear, the oil was heated and the slots were finished. Here, discipline was the cure. Slow down in time. Don't try to strangle the terrain. The chassis held the blows of the war with dignity. The front rollers traditionally received an increased load. A heavy artillery piece and a reinforced forehead shifted the balance forward. This increased tire wear and required attention to the condition of the bearings. But here's what's important. This wear and tear was predictable. The crews knew when to expect problems and prepared replacements. The trucks, a rough but honest detail, stoically endured asphalt, stubble, and clay. On crossings over rocky terrain, fingers sometimes fell out, but experienced mechanics immediately caught the symptoms by sound and vibration, without bringing the tracks down under fire. The shock absorbers of the recoil of the cannon worked smoothly, and the gunner did not swear at the goat after the third shot. The recoil was extinguished predictably. The return to the aiming point occurred quickly. The armored hull and cabin are assembled without frills, thickened forehead, rational angles, simple geometry to keep welding stable. The main enemy here was not the Germans, but haste. With poor edge preparation and insufficient heating, cracks could appear at the loaded joints, especially around the mask. Technological maps treated this disease. Where to strengthen cutting, where to lay the lining, where to raise quality control. In the field, cracks were caught in a timely manner, and the repair crews were able to put patches in such a way as not to deform the landing of the cannon. Cabin ventilation is another household topic. Intense shooting without the discipline of purging quickly saturates the air with gases. On the SU-100, this was solved in two ways. The fire mode, short bursts, position change, and ventilation along the way. and modified fans with normal wiring that does not burn out from temperature. The main pride is the art part. The D10S provided not only ballistics, but also the character of a shot that you can live with. A soft rollback, adequate efforts on the flywheels, predictable rollback operation. Separate loading remained a controversial compromise. It required training, space, and rhythm, but it offered fault tolerance and flexibility in the range of ammunition. The secret is how the laying is organized. The running types of shells are closer. The rare ones are deeper. The trajectory of the loader's movement is without unnecessary intersections with the gunner. A well-coordinated calculation gave out the pace that the designers had originally set. And if someone tried to, quote, make a movie and shoot like a machine gun, the system reminded them of itself. Accuracy was disappearing, burnout was growing, and they had to return to the norm. Optics and surveillance are quiet heroes. The commander's turret with an all-round view, decent sights, clear scales for the main types of ammunition. All this did not look sensational, but it directly reduced the human factor. The commanders lost less targets when changing positions, and the gunners were less confused with the corrections. The radio stations loved dryness and normal cable routing. They took this into account on the SU-100. They took the wiring away from hot zones, put fasteners that do not loosen on short waves of vibration. As a result, the relationship ceased to be a fetish and became a tool, as intended. Now let's be honest about the weak points. The first is a limited horizontal guidance sector. Any mistake in choosing the starting position was punished with extra seconds to turn the hull. There is only one cure. Topographic discipline, pre-targeted landmarks, pockets for displacement. Work in pairs with overlapping sectors. The second is the cramped cabin. In the rush of the assault, it was possible to stumble over each other and lose seconds. It was solved by training, the iron arrangement of objects, the habit of command words. The third is close-range defense. Without a coarse machine gun, the car needed infantry. And if they lagged behind, the crews improvised with landmines and submachine guns through the embrasures. No romantic illusions. The self-propelled gun was created not for street boxing, but for a long-range rational strike. But where her field was playing, the SU-100 demonstrated exactly how it drove and shot. At a range where the D10S confidently solved the target, the crew felt free to choose the moment. On the march, the mechanic wasn't playing roulette. He was driving a familiar chassis that forgives minor mistakes and the wrong rhythm of the road. The crew did not depend on a rare tool for maintenance. What was supposed to be done in the field was done in the field. Unification with the T-34 cut the tails of problems. Candles, filters, gaskets, oil seals. All the little things of life are more accessible and understandable than those of exotic relatives. The repair workers did not fall into a stupor at the sight of another new car. They know the scheme. They remember the control points. The order of work is standard. A special conversation is time for failure. In a combat unit, this indicator is measured not by the laboratory, but by the nerves of the commander. If a battery has declared a firing line in the morning, it must reach there, take up, shoot, work out a series, change position, and return to readiness. That's it. Any technique that disrupts this cycle destroys the plan. The SU-100, with its familiar engine, predictable gearbox, fair running gear, stable artillery, and clear regulations, withstood this cycle more often than not. And this is the main compliment that can be paid to a war machine. Not the most perfect, not the most modern, but the most uniform in business. Of course, Soviet reliability is not a fairy tale about the ideal. This is the ability to recognize the boundaries of the machine and play inside them without heroic naivety. The anti-tank task is the main one. Range is the currency. Position is the capital. The more carefully they spend their currency and save their capital, the longer the crew lives, and the more often the iron remains iron and not a monument. This is the point of the story about the SU-100. It did not promise miracles. It offered an honest exchange. Discipline and competent operation in exchange for a stable result. When the technology level is compared later, the car may be called simple. But simplicity is not poverty, but sufficiency honed to the right functions. The cannon that hits, the chassis that carries, the regulations that are carried out by the hands of ordinary people. That's why the expression drove and shot stuck as a formula of trust. This formula survived the war, migrated to textbooks and post-war parks, where the SU-100 kept itself in check for a long time. And the idea that has lived the longest is not to chase the effect where predictability wins. Next, the legacy story will take over. How the D10 moved to the T-54-55 towers, how the Czech SD-100 went into export, and how the experience of simplicity with character shaped post-war operating standards. But the key has already sounded. Reliability is a style of thinking, not an epithet, and the SU-100 mastered this style perfectly. Military technology stories rarely end with war. Sometimes it's a peaceful pause that shows what was really done right in the car. The legacy of the SU-100 is not only the museum sides with white numbers. This is a network of factories outside the USSR. Dozens of armies that adopted the machine as a workhorse. And, most importantly, the fate of its tools. The D10 will move from a self-propelled wheelhouse to a tank turret and live a long, almost half-century-old life, remaining as relevant as possible for the barrel of yesterday. Immediately after the war, the design and production DNA of the SU-100 began to spread across Europe. In Czechoslovakia, a licensed release was established. Locally labeled machines, commonly referred to as SD-100. The scale here is not only in numbers. More importantly, the Czech metalworking school and stable quality control have consolidated the reputation of self-propelled guns as even. It is smooth, without bursts of novelty, but with predictable release and maintainability. This Prague accent is also noticeable in training units, where well-maintained vehicles have served for years as training classrooms for mechanics, gunners, and commanders. The very course rides and shoots in its purest form. The geography of subsequent exports is easy to read on the map. Eastern Europe, the Middle East, Asia, and later Africa and Latin America. Everywhere, the SU-100 occupied the same niche. A long-range regimental, divisional-level anti-tank weapon with a clear supply base and moderate crew training requirements. But the real long shadow stretches not from the hull, but from the trunk. The D-10C, a self-propelled variant, became the matrix for the D-10T, a tank modification with a turret shoulder strap. Changing the carrier required a different balance of the swinging part, a different stabilization unit and reworking of the aiming ones. But the basic ballistics remained the same. A high initial velocity of the armor-piercing projectile, decent flatness, and a resource of upgrades. In the T-54 tanks, and then in the T-55, this gun went through several turns of evolution. From simple, daytime firing on tables to stabilizers in two planes, from optical rangefinders to laser devices, from the classic BR projectile to low-caliber arrows, and cumulative with more predictable work on inclined armor. The technical steps are small but continuous. In total, they kept the D-10T in service for so long that the very name Petrov became synonymous with the stubborn vitality of the Soviet art school. It had a simple effect on the strategic layouts. Where countries could not afford rapid rearmament, the weaving provided a clear plan to modernize not the body, but the meaning of the shot. New optics, a different stabilizer, fresh ammunition ballistics, and now the old silhouette shoots in a new way. The D-10T became that rare case when the evolution of the environment, observation devices, correction calculators, rangefinders, allowed the older caliber to remain in position for a long time. This is the long shadow, when the same tube, clad in new devices and powered by a new ammunition line, remains a threat to the armored target, which is 2 generations younger than it. The SU-100's combat footprint in the post-war world has not disappeared into the archive either. In the Middle East, the car has played the role of a wooden wedge in the stone wall of oil geopolitics. In the Suez Crisis and subsequent Arab-Israeli wars, self-propelled guns were used the way they were taught on the Eastern Front. Ambush positions, targeted landmarks, short bursts, and mandatory point changes. Sand and heat were treated with a maintenance regime. Filters, purging, marching discipline. At long distances, flat spaces offered a chance to implement ballistics, and the high contrast of silhouettes helped observers. Yes, the enemy quickly learned to bypass static pockets and hit the identified lines with artillery. But the self-propelled guns also mastered night movements, camouflage, and the breakdown of positions with a snake so as not to leave geometry for the gunners. In this game, the SU-100 was important not as the main character, but as a reliable part of the overall defensive mosaic. Another important position is coastal and stationary defense. Where the budget and the landscape forced improvisation, the SU-100 was turned into fixed pillboxes with a living soul. An excavation in an embankment, a concrete sarcophagus with a ramp, disguised as a warehouse or workshop. Of course, such a fate is the path to museum eternity, but in specific circumstances it was rational. When there is a precise tool with well-learned logistics at hand, it is unprofitable to throw it away while it closes the real hole. So the long shadow of the SU-100 also fell on the fortification. Quiet, not frontline, but economically understandable. In Eastern Europe, the self-propelled gun went through another round. The transition to training and reserve units. For the Warsaw Pact armies, it was an ideal simulator of a complex firing task. Wide caliber, serious impact, strict requirements for topographic thinking. The SU-100 did not teach heroism, but craft. How to anticipate location errors, how to distribute tasks in the battery, how to count the time of position change and the window between the enemy's targeting and his own series. What was born out of need in the war turned into a school of tactical literacy in the world. Meanwhile, the tank line continued to dictate the agenda. In the T-55, the D-10T gun received, step by step, the electronics that there was nowhere to attach to the self-propelled wheelhouse. New generation stabilizers, sights with built-in rangefinders, night vision devices, and later, laser rangefinders with semi-automatic correction. The combination of old gun plus new eyes turned out to be surprisingly competitive in a world where not everyone can buy the best thing. Ammunition was also maturing. Sub-caliber ammunition was reinforced with cores and fitting for channels. Cumulative ammunition grew in penetrating power, and high explosive fragmentation remained a traditional universal against field fortifications. And manpower. Yes, the long feathers of the next generation of BOPs were already looming on the horizon. But in the massive conflicts of the second half of the 20th century, there were enough weaves to solve the problems of real combat. Not an exhibition, but a dusty one. There is also a cheaper-to-own aesthetic in this story. Factories, spare parts, repairmen, training programs. All this is a cultural layer that is more difficult to build than to buy a batch of fancy cars. The SU-100 and its daughter, the D-10T, have integrated themselves almost perfectly into this ownership economy. They did not require exotic alloys, ultra-precise machines from a single factory, rare oils or appliances that had to be flown to another continent. This gave rise to a special type of trust. The commanders knew that the equipment would survive the calendar plan, not the presentation plan. When priorities changed in the armies, the 100 could be transferred from the first line to the training line, from the training line to the reserve, and then to long-term storage or to stationary firing points. Every role is possible. The legacy of the D-10 is perhaps the purest lesson in engineering sufficiency. The gun, conceived as a response to the 1944 frontline challenge, did not disappear into the museum dust, because it was laid not for effect, but for resource. A large margin of safety of the nodes, a pleasant return for mechanics, the modernization potential of the sights and chassis. All this allowed the D-10 pedigree to live for decades. And when we say, from Prague to Suez, we don't mean the geography of the parades, but the trajectory of meaning. From stable, licensed production to real wars. From classic, self-propelled artillery to tank evolution. From tactical tables to the framework of the ownership economy. Which line should I sum up? Perhaps with the one that has already been mentioned before. Reliability is a style of thinking. The SU-100 proved this in the war, and the D-10 proved it in a world where novelty quickly depreciates if logistics and learning skills are not behind it. The long shadow is not about nostalgia, but about the ability of a design to remain useful when the fashion has changed 3 times. A mature barrel, disciplined mechanics, and an honest task. These are the 3 pillars on which the SU-100 itself and its tank legacy rested. And while somewhere in the sand, steppe, or landfills you can still hear the low bang of 100, it's clear. The lesson of 1944 is not over. He just moved to another class, where they evaluate not the volume of promises, but the evenness of the work.